Throughout history, astronomers from Hipparchus's time to the present day have looked to the stars to tell us something about the universe we inhabit and to understand how we got here. The European Space Agency is about to launch Gaia, a dedicated astrometry satellite that will map 1 billion stars of our Milky Way, unlocking the structure and history of our galaxy. To do this, Gaia will look at the galaxy from an extremely stable orbit far away from the Earth's atmosphere around the Lagrange point 2. To cover an area as large as possible with detailed precision, Gaia will scan the sky with 2 telescopes set at a 106.5-degree angle, while at the same time gyrating on a tipped slant called a precession axis.
By combining the spinning and the precession, the spacecraft is able to scan the full sky. Actually, more than one time. It is scanned something around 70 times in the full life of the spacecraft, which is 5 years.
Gaia will have 3 instruments on board that will allow it to map the sky in unprecedented detail. An astrometric instrument will measure the position of stars, while a photometer will deduce the temperature and chemical composition of celestial objects by analysing their colour spectrum. And finally, a spectrometer will measure the speed at which objects are moving towards or away from us. It's the combination of all 3 measurements that will enable scientists to get a better understanding of the evolution of the Milky Way.
Never before there is a kind of large survey, an homogeneous survey, like the Gaia will be. So the combination of the properties of the stars plus the motion of the stars will tell us families of stars, and make us to reconstruct the history of the galaxy. But the key point is this large amount of data with such high accuracy in the positions and distances and motions.
But it's not just the stars that Gaia will be mapping. Its data harvest will be of almost inconceivable size and is expected to contain the discovery of thousands of new celestial objects, including asteroids, comets and exoplanets, as well as stars of all ages.
By far, most of the objects Gaia is going to detect are stars, because Gaia is optimized for stars. But we are also going to observe solar system objects, we are also going to see extragalactic objects, and this will be a database which will be used by the scientists worldwide when the Gaia data is made available for them.
It's likely that the extent and precision of Gaia's measurements will make its findings the main reference for scientists for years to come.
Almost all of the fields in astrophysics will be affected or will be in some way, touched by the Gaia observations.
Gaia will help us delve into the archaeology of the Milky Way, helping us to understand the history, the formation, the evolution, and maybe even the origin of our own galaxy.